All right, so let's take a look at this one. We have r equals 2 over 4 minus 4 cosine theta. Right away, I'm seeing cosine theta. So that tells me that my directrix is going to be perpendicular to the polar axis. And it's going to be, because of the minus, it's going to be to the left of the pole. All right. Well, first, let's go ahead and simplify this. We can reduce everything by a factor of 2. So this is 1 over 2 minus 2 cosine theta. And really, we really want to make sure that we have a 1 right there. So let's divide everything by 2 again, which makes this 1/2 in the numerator over 1 minus cosine theta. Now, in this form, we can see that means that e is equal to 1, because that's going to be the coefficient that we have right there, as long as you've got a 1 in that spot at the beginning. So if e is equal to 1, that means that we are dealing with a parabola. Okay, got a parabola, and our directrix is just going to be our directrix, right? And if the directrix is perpendicular to the polar axis, that means it's vertical. That means we're going to be dealing with a sideways parabola, right? Let's see if all that stuff is going to make sense when we put it all together. Now, this numerator right here is supposed to be e times p. So since e is 1, that means the p value equals 1/2. Okay, so let's see what we can do with this guy. Boy, that is really crooked. You'll get over it. So that means my focus is always going to be here at the pole. That's what we say. The directrix is going to be 1/2 of a unit to the left because of the minus. Okay. I'm actually going to change my scale here a little bit. I'm going to say this is going to be 1/2, or negative 1/2, and this is going to be negative 1. Whatever you do with your scale, make sure that you are applying it consistently whenever you graph. So don't say, 2 units is a half or 4 units is a whole on the left and then change it up on the right. That doesn't make any sense. All right, so my directrix is going to be this guy right here. Now, if this is my focus, my vertex should be in the middle. It should be right here, which would be the ordered pair negative 1/4, comma 0. Now let's see if that actually holds up. So we're talking about cosine. So what if I plug in 0? If I plug in 0, that's going to give me cosine of 0, which is 1. But then 2 minus 2 is 0, so this is actually going to be something that I can't do, right? But what if I do pi over 2? If I plug in pi over 2 here, so I do pi over 2, cosine of pi over 2 is 0. So this would give me 1/2. If I plug in pi, so plugging in pi means that I would have 2 plus 2, which would make that 1/4, so that's going to give me 1/4. And if I were to do, say, 3 pi over 2, just to make sure I feel really good about my graph, that's going to give me another 0 here for cosine, so that's going to give me 1/2 again. All right, so let's plot these points and see what it gives us. So when I'm facing pi over 2, so I'm facing straight up, it's going to be 1/2. So the way that we are defining our the units here, each square is going to be a quarter, so 2 squares is going to be a full half. When I'm facing over here in the direction of pi, I'm a quarter, which I already have that marked. I feel pretty good about that. And then I have 3 pi over 2, so facing down is going to be at 1/2. Okay, well, I'm supposed to be drawing a parabola, so I would imagine that my parabola looks like this. And we can even curve it down over here. So yeah, there we go. Now we could convert this into the rectangular form. If we were to look at this picture right here, we have a center at -1/4, 0. It opens up to the side positively. So we'd start by saying y, hold on. The y is going to be perfectly fine as staying as y squared. It's the x part that's going to be x plus 1/4. And then it would be times 4a. So that would just be the difference between the vertex and the focus. So it would be 1/4 times 4, which is just going to be 1. So yeah, this would be the equation. Y squared equals x plus 1/4. So here's what I want to do. I'm actually going to change the mode. And if I change this to function mode, I'm going to do two pieces here. I want to do where I take the square root of this. So it's going to be the square root of x plus 1/4. I guess I don't need that. Still thinking about old school ways. Maybe I should just change the way this looks. Yeah, that's the ticket. All right, so if I graph this, it should be that sideways parabola, just like I was talking about, right? Let's change the mode and go back to polar mode and do 2 divided by the quantity 4 minus 4 cosine theta. And it's the same thing, right? The exact same thing. So that was pretty fun. Let's try another one. Ooh, r equals 12 over 6 plus 8 sine of theta. Well, right away, I can see that we're dealing with sine, so that my directrix is going to be parallel, so it's going to be horizontal relative to that polar axis. Let's do some reducing here. And in fact, you may just want to go ahead and say, you know what, let me go ahead and divide everything by 6 because I need to get this guy to be a 1. So I'm going to divide this by 6 and the denominator by 6 as well. So we have 2 over, that gives me 1 plus 8 over 6 reduces to 4/3. So there we go. Because we're in this form, that means that we can quickly and easily identify the e as being 4/3. What about p though? This guy is e times p. So doing a bit of work here. So e times p is 2. E is 4/3. And I want to get rid of that 4/3, so I multiply times 3 over 4. And then we reduce. So those guys are gone. 2 reduces with the 4 2 times. P equals 3/2. Right? Also, since e is greater than 1, we are dealing with a hyperbola. Oh, I can tell this is going to be loads of fun. Okay, so let's start drawing this, put things in place, and see what we have. Now we're dealing with some fractions. The p is 3/2, so I might want to let each square represent half a unit. That might give us a little bit more room to work. All right, so we know that we have one focus is always going to be at the origin. That's a very, very nice thing about what we have here. Focus is always going to be at the origin. So the p value tells me my directrix is going to be 3/2 units. In this case, since it's a plus in front of the sign, that's going to move it up 3/2 units. And again, if I make each of these be 1/2, it's going to be up here that. So we'll get that going. Oh, now what? Well, this is where you start plugging in values, especially we want to plug in pi over 2 and 3 pi over 2 for sine, and that will give us those values for our vertices. At least it should, right? So let's check that out. If I plug in pi over 2 for theta and then 3 pi over 2, what happens? And because I've got the fraction stuff right here, maybe I don't plug it in that spot. I think it might do us better if I try to plug it in here at the original, pi over 2. All right, so sine of pi over 2 is 1. So I end up with 12 over 6 plus 8, which is 14. So 12 over 14 is 6 over 7. Yeah, that's not fun. If I do 3 pi over 2, so 3 pi over 2 would make this a negative 1. So then we would have 12 over 6 minus 8 is negative 2, and we get negative 6. So negative 6. Yeah, totes fun. It probably wouldn't hurt us to plug in some extra stuff if I plug in 0. Sine of 0 is 0, 12 over 6 is 2, and if I plug in pi, that again is going to give me 0, and that's going to give me 12 over 6, which is 2. So I'm just doing that to get a little bit more information and some nice points here. All right, so when I'm at 0, I'm at 2 units. Gotta make sure I remember how I did this. So 2 units is going to be over here. And when I'm over here at pi, it's also going to be 2 units. When I'm facing straight up, it's going to be 6/7, so somewhere right about here. And when I'm facing down at 3 pi over 2, I'm actually going to be backwards 6 units. So that's going to tick me off the grid a little bit. Well, what if I just take this and I'm going to slide it down. There we go. See, nobody has to know. So I'm going to just extend this up. And if I want to do 6 units up, so it's going to be 1, 2, 3, 4, 5, and 6. All right, so we're talking about a hyperbola. So my expectation is that it's going to be doing something like this, and something similar on the other side like that. And I expect you to be doing the same thing because of symmetry, to be doing this. All right, so we have, in terms of the rectangular coordinates, we have 0, positive 6, and here we have 0, 6 over 7. That's going to be for our vertices. Well, where is the center going to be? Center is going to be somewhere right about here. And the way we find that is just by doing the midpoint, right? So we need to figure out what is the average of 6 and 6/7. All right, so let's scoot this down just a little bit and figure that out. So I need to take 6 plus 6 over 7 and divide that by 2. All right, so that's going to be 7. That's going to be 42. 48 sevenths divided by 2 is 24/7. Make sure I double check. Yeah, I agree with that. So the center for this hyperbola is going to be 0, 24/7. And from here, you can find all the other information. You can find your A, you can find your C. So my A value is going to be from here to here. So 24 to 6 is going to make that 18 over 7. And we already know that 24 over 7 is going to be our C value. So we can, plug this in and come up with the B value and get a more accurate graph. But I think what we have here is going to be okay. Let's check and see what we have in the graphing calculator. All right, so we have, what's this, 12 divided by the quantity 6 plus 8 sine theta. Let me just double check. Okay. And let's graph. Okay, so there's this one part right here, but we need to change our window so we can capture the other part. And we would say, let's go up to 8. Okay, there we go. All right, so theta is 0. That's really nice. So it tells me x is 2, y 0. That's kind of what we had. Can I... Oh, you really don't like me to trace along this. Oh, because I've got to go in that order. Okay. Yeah, so you can see tracing along, and there's going to be the key value somewhere right around here, right? And then we could keep on going. And so we should have this key point up here that's going to give us 0, 6 rectangular wise. And, there we go. So yeah, sometimes these problems get a little bit messy, but again, it's just numbers. Fractions are just numbers. We just have to make sure that we stay calm, and we shouldn't have any problems.